All right, so we're going to do section 7.2. So let's take an example here. Let me give you two equations. All right, remember what this is called, Jack? Remember this is called system of equations. Whenever you have more than one, we just call that a system of equations. And what we want to do is find where they intersect. We want to find, just like we did yesterday, but we're not going to use the graphic method. Today, we're going to use the substitution method. All right, substitution method. Well, isn't x and y at the one point where they're the same, isn't x and y the same in both these equations? So if y is equal to 3x plus 2 in that equation, then y is going to equal 3x plus 2 in the second equation. So what I'm going to do is I'm going to write this second equation, x plus 2y, but instead of writing y, I'm going to put what y is equal to. And what is y equal to?
3x plus 2.
3x plus 2. So I'm going to put that right there. And that is going to equal 11. So I took what y is equal to in one equation, and I put it into the other equation for y. Watch what happens now. I have x plus 2 times 3x is 6x. 2 times 2 is 4. And that equals 11. X plus 6x is 7x. Plus 4 equals 11. Subtracting 4 from each side. And 7x equals 7. And divide by 7. And so x equals 1. Well, I know one part of it, x is 1. In order to find y, I can put it into either one of the original equations. I think I'll put it into the top one. If x is 1, then y is equal to 3 times 1 plus 2. So y is equal to 3 plus 2, and y is equal to 5. This is called the substitution method. I'm going to give you a couple other examples. The original equations, y equals 3x plus 2, and x plus 2y equals 11. My solution is 1 and 5. So if I put in 1 for x, 3 times 1 is 3. 3 plus 2, yeah, y is 5. So it works in the first one. If I put in 1 for x and 5 for y in the second equation, 1 plus 10, it works in the second one. It's the only point that will be a solution to both those equations. And that's called the substitution method. So let's try another one. Did you not get all that next? No. Okay. All right, so we're going to try a second equation here. Okay. Oh, good? All right. And let's take 3x plus y equals negative 7, and negative 2x plus 4y equals 0. What I want you to look for is I want you to look for a variable where we have a coefficient of 1. Well, not this one. This has a coefficient of 2. This has a coefficient negative 2. This has a coefficient of 4. This has a coefficient of 3, but this has a coefficient of 1, right? 1y. That's what I want to look for. So I want to take 3x plus y equals negative 7, and I want to solve for y. Okay, in order to solve for y, I'm going to subtract 3x from each side. And this tells me that y is equal to negative 3x minus 7. That's what y is. And what am I going to do with that? I'm going to do what? I'm going to sub it in for y. I'm going to take what y is equal to in one equation, and I'm going to put it into the other one for y. So now I have negative 2x plus 4 times y, which we said was negative 3x minus 7, and that equals 0. The result is I have an equation with only one variable. I can find out what x is. So negative 2x, and let's distribute. 4 times negative 3x is negative 12x. And 4 times negative 7 is negative 28, equals 0. Follow me so far? Negative 2x minus 12x is negative 14x minus 28 equals 0. I strongly suggest you guys to show your work, because there is a chance to make errors. Add 28 to both sides. Negative 14x equals 28, and divide by negative 14. So that x equals, what is 28 divided by negative 14? Negative 2. Okay. My solution, negative 2, that's what x is. I just found out what x was. And how do we figure out what y is? Plug it back in. I could plug it in here. I could plug it into the top one. I could plug it into this one here. I think I'll plug it in right there. So that y is equal to negative 3 times negative 2 minus 7. Y is equal to a positive 6 minus 7. Y is equal to negative 1. So these two straight lines cross at negative 2 and negative 1. Zach, you have a question? You look puzzled.
I just don't explain I got coordinates. Yeah, I'll get second.
Okay. Is everybody okay when you got to this point where x equals negative 2? Okay. If you got to that point, then take one of these equations, this one, even this one here, any one of those, yeah, and plug in negative 2 for x to see what you get for y. I took this one here circled in red, and I put in negative 2 for x. Y is equal to negative 3 times negative 2 minus 7. I put in negative 2 for x. And that's where I came up with y equals negative 1. Okay, Ozzy first.
So you're using the x negative 2 as the first word?
Yes. You know, what if you decided to use it into the equation negative 2x plus 4y equals 0. What if you wanted to use that equation and put in negative 2 for x? You would have negative 2 times the negative 2 plus 4y equals 0. I have 4, that's positive 4, right? Plus 4y equals 0. Subtract 4 from each side. 4y equals negative 4. We'd still get y equals negative 1. So you can plug it into any one of the equations and it'll still work. You want me to do one more for you?
Yeah.
Okay. Are we all caught up here on the notes? All right. Well, let's pick out another one. All right. Let's take 5x plus 4y equals 32. And we'll take 9x minus y equals 33. All right? It doesn't matter that we have big numbers. It really doesn't. The first thing I'd ask you guys to do was to look for a variable that has a coefficient of 1. If you look at the top equation, what are our coefficients? 5 and 4, right? I'm going to leave that one alone. Look at the second equation. I've got 9. Yeah, I've got a 1 there. I've got a y all by itself. So I want to solve for this y. Does that make sense? All right. Uh-oh.
Right-hand corner. Right-hand corner. No, up. No.
That one. That one. All right. Thank you. Okay. So let's take 9x minus y equals 33 and solve for y. What would you do to solve that for y? Minus 9x? Okay. So that's minus 9x. And then I have negative y equals negative 9x plus 33. And then what? Divide by negative 1, right? Notice I'm dividing all three. Here I get a positive y. Here I get a positive 9x. And then negative 33. That's what y is equal to. Okay? So I want to take this information, that's what y is equal to, and I'm going to put it up into this first equation in place of y. Okay? So I have 5x plus 4y, but instead of y, I'm going to write 9x minus 33, 5x plus 4y, and what does that equal? 32. Yes, Zach? Okay. All right, well, let's do the work here. We'll distribute. 4 times 9 is 36. And 4 times negative 33 is a negative 132. And that equals 32. 5x plus 36x is 41x minus 132 equals 32. And then I'm going to add 132 to both sides. I'll have 41x is equal to 164. And divide by 41. What do you think I'm going to get?
4.
x equals 4. So I'm halfway there. I found out what x is equal to. How do you find out what y is equal to?
Take one of the equations and sub in x for 4.
Perfect. Take one of the equations and put in 4 for x. I could take this one up here. I could take this second one here. I could take this one here. This one might be easier. This tells us what y is. So y is equal to 9 times 4 minus 33. You follow that, Zach? So y is equal to 36 minus 33. Y is equal to 3. 4 and 3 now is the solution. Okay? Now, like I told you, there's only going to be, and that's pretty much what this lesson is. But we're going to take 2 days on this because I know it can be confusing and I want to help you guys as much as I can. So I'm going to give you just a few problems to do. I'll give you maybe 5 problems, 5 or 6 problems today, and then we'll go over this again tomorrow. I want to make sure, please make sure that you do your homework though. Make sure that you're trying every single problem. All right? So your homework is going to be on page 439. And I want you to do problems 3 through 8. And I'll give you about 6 problems to do. Right? And please have all those problems done by tomorrow. All right? That's the end of our lesson today.
Okay, this is the part that I was confused on.